In this video, we're going to be talking about direction angles. So let's say that we have a unit vector that we'll call u, and that we have this angle theta, okay? Well, that tells us that our terminal point of view is going to lie on the unit circle, because remember, if I have a unit vector, I only have a magnitude of 1, right? So I have my terminal point here, and so that's our x comma y, and thinking back to our unit circle, we also called this cosine theta comma sine theta. So that's another way to think of this terminal point here that's on our unit circle, which means that as I write u in component form, that I would have x comma y, or I could also write cosine theta comma sine of theta. And those would be my component forms. Now, if I wanted to write this in linear combination form, I would simply write that I have the cosine theta of I plus the sine theta of j. And so our theta is our direction angle. So we have our vector u that has a direction angle of theta. So let's say that we had a vector v, and let's say that it's a times I plus b times j. And it makes this angle theta with the positive x-axis, just like u. Well, that tells us that it has the same direction as u, which means that v is really a scalar multiplication of u. So we can rewrite v like this. So the magnitude of vector v times our component cosine theta sine theta. And we can rewrite that as well in linear combination form, like so, where we have our magnitude of v times the cosine of theta times I plus the magnitude of v times sine of theta times j. So for example, we can see how this works. If we were to say that our vector v had a magnitude, so if it had a magnitude of 4 and it made an angle of 45 degrees with the positive x-axis, we'd be able to write it like this. 4 times the cosine of 45 times I plus 4 times the sine of 45 times j, which would then give us 4 times the square root of 2 over 2 times I plus 4 times radical 2 over 2 times j, which is going to reduce to 2 radical 2 I plus 2 radical 2 j. Now, because we know that vector v is a times I plus b times j, which also equals our magnitude of v times the cosine of theta times I plus the magnitude of v times the sine of theta times j, it follows that if we're looking for the direction of theta for v, we can determine that from tangent, right? So the tangent of theta, as we know, is sine of theta divided by the cosine of theta. So in this case, we're going to have the magnitude of v times the sine of theta over the magnitude of v times the cosine of theta, which we can see from up here that our a is simply our magnitude of v times the cosine of theta, and that our b is the magnitude of v times the sine of theta. And so we're actually able to just rewrite this as the b divided by the a, and that will help give us our theta. And from there we would just find the inverse of tangent of b over a, and that would give us our theta.